Hi, everyone, and welcome to today's webinar. My name is Max Steele, and I'm the Director of Product at Domino Data Lab. I'm joined today by Mike Gualtieri, VP and Principal Analyst at Forrester, Sammy Jern, who's a data scientist at Bayer, and we're going to be discussing how leading organizations are solving the ModelOps challenge. The agenda for today is Mike is going to go first and sort of set the scene, given his position as a leading analyst in the field, who can help sort of give us a common language to discuss this. I will be covering how Domino addresses some of the ModelOps challenges that Mike will frame. And then Sammy, who's a practitioner, will describe how they are addressing these challenges specifically at Bayer. Before we get too far into this, a few quick housekeeping notes. We will be recording this webinar and sending it out within a few business days to all of the different attendees to the email address that you registered with. We're not going to take live questions during the session given the number of attendees, but if you have questions, feel free to leave them in the chat or the questions section of your webinar control panel, and we'll be following up directly via email. Lastly, the best audio experience for the webinar is the broadcast audio option via your computer speakers. If you would like to dial in via a phone line, please request one through the chat. And with no further ado, I'm going to turn it over to Mike and let him describe what he's seeing in the world of ModelOps.
Thank you, and hi everyone. My name is Mike Gualtieri, Principal Analyst at Forrester, and I cover data science and machine learning. And what I'd like to talk to you about today is the trends that we're seeing in model operations, and specifically for data science at scale in enterprises. Never been a better time to be a data scientist, especially at large enterprises, and that's because of artificial intelligence. There's a lot of interest in artificial intelligence, and at Forrester, we think that AI and the machine learning models behind it are going to dominate in enterprise innovation, certainly now, but for years to come as well. We can see this in some of our recent data that, the number of companies saying no to AI is declining, the number of companies over the last 3 years saying yes is increasing, and you've got over 50% of companies saying that they're doing some form of artificial intelligence. And we think that those companies that are saying yes to AI, whatever they're doing, they're probably just scratching the surface. So there's a lot of opportunity. We define AI in two ways. There's the pure AI, that's the sci-fi stuff, and then there's pragmatic AI, and that's what we're talking about here, and that's what data science is about. It's about creating machine learning models that will power predictions, decisions, recognize patterns. And the great thing about it is there's literally hundreds of use cases, because if you think of all of the applications in an enterprise and the business processes, all of those have a potential value for use cases. And we did a recent survey very recently in April of 2018, and in fact, most enterprises agree, right, that there's a sweeping number of use cases. So, I mean, what this is going to mean is it's going to mean that data science has to scale. It has to scale to create all of these dozens and hundreds of models over the next couple of years. And that's what data science is about. Our perspective on data science teams in the enterprise is that they have to collaborate with stakeholders, obviously, to explore those data and to develop those machine learning models. That's what you do, right? And that process is pretty well understood, collecting the data, running the models, but then on the left side, there's that deployment and retraining. This is the process, and this essentially is the process that has to scale on those use cases. The problems that data science teams report are many. And you can see here they range from the left that, they had trouble building the model either because they couldn't get the data, it wasn't the right data, up until not having the right tools, and then they couldn't deploy it, having to do with a few other situations like acceptance by the users and also developed apps. And let's look at a couple of those key ones that are sort of one of the key ones for ModelOps. So data scientists, in many cases, have to beg for adequate infrastructure. A lot of data scientists, they're trying open source. They're running under their desk, or they're running on limited servers. Sometimes they have access to the cloud. And it's not just an issue that they don't have availability because you have a lot of availability in the cloud. But there's the provisioning and having access to the data sources as well. So one of the things essential for ModelOps for both training and deployment is having that adequate infrastructure. The other big problem with data science teams is that a lot of the UX and software development teams within the enterprise don't actually know how to design machine learning models into the applications and business processes they use. And this is a problem for data science teams because data science teams are doing those models, but they're not familiar with the application. So there's a sort of a lack of collaboration. And this is, more than anything, this is an essential link that has to be established between building the models and deploying those models. That's a key principle of model operations. And in many cases, the business professionals who run the business also lack an understanding of how the model works, how it's used, and how it enhances business outcomes. So, the idea behind ModelOps is to help data science teams overcome those challenges. And, our research has showed that there's a fundamental misunderstanding between traditional operations in software development and data science. And a lot of that misunderstanding is centered around the idea that models are probabilistic, right? And if you think about that, you know it because you're a data scientist that models are probabilistic. Software developers are used to developing deterministic code. Get back to that in a second. So once that model is deployed, it's probably going to decay, right? The performance of that model might decay to a point where you can't use it. So you're absolutely going to need to retrain a model. And that has implications on infrastructure because the same infrastructure you needed in provision to train needs to be available for retraining as well. And there's also the case where firms are going to compete on the accuracy, so they may even remodel that application. And here's the fundamental misunderstanding, because that idea of probabilistic models and the need for retraining is in direct opposition to the idea that program code will always run as written. Certainly it'll have bugs, right? But the deployment process is very different. When you deploy new code in an application, you've deployed that code. You don't retrain code, right? You may refactor it, you may rewrite it, but you don't retrain it. So there's a fundamental misunderstanding between DevOps, Ops, and software development versus what happens in the data science process. And this is an idea that's needed in ModelOps, right? So for code, it's deterministic. You may refactor it. That's a well-understood process in most enterprises. It's the DevOps process. ModelOps process is different. The ModelOps process requires the infrastructure necessary to retrain models as they decay. And if you think about it, if you think about the total use cases, and as the number of use cases expand, the ability to deploy models and then on a regular basis retrain those models, that becomes a much more sophisticated process than a typical code DevOps deployment. And companies basically are not going to be able to do it without tools. So they're going to need to stage models to test that data on production data. You typically see capabilities in ModelOps capabilities like champion challenger, A/B testing of models. You have to monitor those models against KPIs and do statistical tests to make sure they're performing, to understand when they need to be retrained or even shut down for performance reasons. And the DevOps collaboration has to have a very repeatable model deployment process. And this is part of that disconnect between what it means to deploy code versus models, because models are continuous. It's data and code together with a retraining process. So these are some of the capabilities that ModelOps needs to establish links. And we have this term that we've been using and others in the industry have been using called ML engineers. And they understand the challenges of getting models into applications because they understand the model development process. They understand the data science lifecycle, but they also understand the software development and ops process as well. So here's a diagram of some of the roles involved. and where the ModelOps capabilities are necessary to establish some of these links. Now, tools are going to be necessary, and one of the things I do as an analyst is I cover the tools market for machine learning solutions. And we've seen a real focus in the past on the training part of the life cycle. That's inadequate to operationalize AI solutions. And now we're seeing people even use this term ModelOps, which means to scale this whole process of deploying models and retraining with the collaboration among the other parties. So tools are necessary to do that. And a recent Forrester wave that we did, we had an entire criteria section focused strictly on model operations, where in past waves we were just measuring the ability to deploy. How can a model be deployed? But what we found is critical, and what we find that enterprises are asking for now is this full model ops capability that I just talked about. Here's our most recent wave that we did in Q3. This one was focused on notebook-based machine learning solutions. And one of the characteristics of the leaders is across all of those criteria, but many of them were specifically strong on model ops as well. So it's all about the ability to scale and the ability to scale to hundreds, perhaps thousands of use cases across the entire enterprise. When we talk to enterprises now, they say, yeah, I'm doing a dozen, I'm doing maybe a couple dozen use cases, and that would be a company that's doing a lot, right? And there may be multiple models for each use case, but again, we're at the beginning here. And so the ability to scale this is becoming important for enterprises. Enterprises are going to ultimately compete on the accuracy of those models as well. Look, if you don't have a model that makes some sort of prediction or a decision, then all of a sudden you have a model that's 89% accurate, you're thrilled, right? But when your competitor also has a model that's 89% accurate, well, you're gonna compete better if you can make a model that's 93% accurate. So when you start thinking of all the models in production, the need to retrain them and to remodel them, it becomes a much more complicated process than the traditional DevOps. ModelOps is necessary. So data scientists, their success is going to be limited if they can't get those models in production. So they really have to think about the full life cycle of ModelOps capability. I talk to large enterprises about their data science teams and tools all the time, and I talked to one financial services company. They had a little over a team of 200 data scientists. Some of those were data engineers. And that has become a key challenge, especially as those teams of data scientists want to use open source tools, Jupyter notebooks, program in different languages, download other tools. Sometimes it can be chaos without a tool set that can coordinate the collaboration and the team development, and certainly that's a problem at scale. So key advice that we have to enterprises these days is absolutely do data science, create those ML use cases that will lead to AI applications, but to be successful, you're going to have to do ModelOps. So I thank you for your attention, and I'll pass it back to you.
Thanks, Mike. Really appreciate that overview. Really helps set the stage for a lot of what we're thinking about at Domino, and I know that team at Bear has been working on. So jumping over to sort of my section, what I wanted to cover is how Domino is thinking about addressing many of the challenges that Mike laid out in this world of ModelOps. And before I get too deep into it, just a sort of quick background on Domino for those who aren't familiar with this. Domino was started about 5 years ago by some of the technology leaders from Bridgewater Associates, which is the largest hedge fund in the world. We work with large, complex data science teams and organizations that are working to become model-driven. And we've been fortunate enough to be recognized as leaders by some of the analyst community and been able to work with some of the leading investors in the world. But enough about Domino, enough about that. I think the thing that we want to think about is the gap that a lot of people are trying to close that Mike talked about, the ability to be successful not just in developing models but in delivering them. And this is a chart that we have seen a number, and you can see a number of these studies and different research, but we've seen that almost everyone agrees that data science is going to be a key competitive advantage for their organization. That ship has sailed. But when we talk to the companies about the number of models they have in production and how frequently they're updating them, there's an enormous gap between what people aspire to and what they're actually doing today. And Mike talked about some of the underlying reasons, and we think about this a lot. And if we had to sort of synthesize it down to a specific thing, we think of it as people are trying to build out capabilities around their formal organizational capabilities like software development and DevOps without recognizing that there are some fundamental differences about models, and that we think of this as the model myth, that you can't just copy and paste your data management or your software development lifecycle onto how you manage data science because there's some key differences, things around models being probabilistic and others that Mike alluded to. And we think that that is at the core of a lot of the challenges organizations face. As we sort of double-click into that, there's sort of three key classes of problems we hear about. There's a technology challenge. The way of building models and running them requires a different set of technology, constantly evolving toolkits, both open source and commercial, much more computationally intensive hardware. The process of building and collaborating is much different. It's much more like science, and so things like reproducibility become key, and the sort of provenance from a delivered model all the way through to the data that helped generate it. And last, this ModelOps challenge, and this is obviously where we want to spend the bulk of the time today. Models are probabilistic, and so as Mike described, it's critical not only to be able to deliver it once, but constantly be iterating on that, because we've seen that organizations that can do that quickly are the ones that are most successful. And the Domino platform is built specifically with this in mind. I won't go into a lot of detail here, given that for the sake of time, for those who are interested, please check out our website and you can get a longer demo. But ultimately, there's three key layers to this. There's our infrastructure foundation, which allows data science teams to work with the data wherever their data is stored. We have a container-based architecture under the hood that allows teams to both develop and run models using Docker containers and whatever software they need. And then a compute grid, which allows organizations to run on whatever hardware they need, whether that's in the cloud or on-prem. And then sort of in the middle is sort of the core data science lifecycle, that core workflow that Mike described. So on the left side, we have the lab where models are developed using interactive tools like Jupyter or Studio, or programmatically testing many different variations or parameters for a model. And then we move on to the Launchpad, which is more of the focus of Domino 3.0, which we'll go through in the demo. The Launchpad is where your business stakeholders or your application developers can come to consume a model. As Mike said, and his diagram I thought showcased that well, there's a lot of different stakeholders in this process. And so your business stakeholders, even if they're non-technical, need to be able to come in and have a place to consume a model. And your application developers need to be able to consume models as a service using APIs. And that ultimately helps allow you to do this at scale. It's not just one or two, it's dozens or hundreds. And last, the management layer, data science and IT leaders need to be able to govern what's happening across the system. In the demo, I'll give a quick sort of sneak peek of some of this in what we call the control center. And all of this sort of comes back to the things that we focus on at Domino, and with Domino 3.0 is reiterating openness. Domino is not about rebuilding Jupyter or developing new machine learning algorithms. Ultimately, the community is doing a great job of that. We want to make sure that people can use the best-in-class tools. We're very focused on reproducibility. We think it's sort of the key to operating at scale, helping reduce your onboarding time or any key person risk. And last, this idea of end-to-end iteration. So it's not good enough to just deliver a model once. It needs to be able to fit into how a business process works. As Mike said, oftentimes that part gets neglected. And then there's also the idea of how do you mitigate risk by constantly being able to iterate on these models and quickly update them. Specifically on the ModelOps challenge, I think that there's an interesting thing has happened in the community, which is, as Mike, I think Mike touched on this, a lot of the innovation has happened on the development side of the house. And so there's a lot of great new tools that have made it a lot easier to build models, but we're still often sort of squeezing through the same narrow door into production. And I think some of the underlying causes for that are that oftentimes there's not the right technology to run in production. A lot of the organizations we work with, they can't get access to run a server that hosts an app on an ongoing basis. That might take months, and by that time, the model that they built is no longer relevant. It's hard for end users to actually find the results. So a data science team might work for months on something, but if the end users can't engage with it, it's not going to deliver the value they need. And last, this idea of continuous iteration. Too often data science teams toss results over the fence, and then if something goes wrong, there's no ability to trace back and reproduce what happened, and the DevOps team that is sort of charged with that doesn't have sufficient context to do it well. And so with Domino 3.0, we tried to take those challenges on head on. And so we'll go through a little bit more of this in the demo, and Sammy can talk about how they're using these functionalities in her section. However, quickly, there's three key things about this. First is that Domino 3.0 is about eliminating the technology challenges. So the ability to quickly spin up the resources to host a model, whether that's as a Flask app, as an API, being able to then give enterprise security and permissioning to that. So whether those are managed API tokens or separate permissioning for your web application, so that you can give that to a consumer, and they don't need to see the entirety of how the sausage was made around building and developing the model. The second is this idea of delighting your stakeholders. So a lot of the organizations we work with, they have moved, the consumers they work with expect interactive, powerful model products. Static PDF is no longer good enough for a lot of them. And so they want to be able to see everything that's available to them in a single place. And they also want to be sure that it can work with how they want to work. Too many organizations will build something, but then it ends up not getting used. And so Domino supports, in keeping with our principle of openness, things like Flask, Shiny, Dash, Bokeh, real-time and batch APIs, and a lot of other different ways for you to deliver a model into production and keep it constantly iterating on it. Last is this idea of iteration velocity. A lot of organizations we work with, we hear that data scientists don't know if what they do matters, and so they can't see who uses the things they work with, and that is both demoralizing and also sort of just not a good product management practice. So Domino 3.0 allows you to see who is consuming your models and also automatically preserves different versions of them and allows you to trace back. So you might have an API that serves a request. You can trace back to the exact version of the model that created that, then to the project that created that, the data that was used, software that was used. And ultimately, that full line of reproducibility is critical not just for regulated industries, but allows organizations to collaborate and build ever more powerful models, especially as they move from doing dozens to hundreds or thousands of these at a time. With that, I want to jump over into a quick product demo. Again, I won't have sufficient time to talk through all of this, but if you're interested, please check out the Domino website for more details and a longer demo.
Jumping into a quick demonstration of the platform, I don't have time to go into the full details of Domino, but I want to highlight the three key areas of Domino and then focus a bit of time on the new features within Domino 3.0. So I'll cover the lab, the launchpad, and the control center, which I discussed a moment ago. First off, in the lab, you can see that your work is organized into projects. And so jumping into a project, you can see all of the files and all of the work happens within this project container. So the main ways that people use this is the workspaces, which allow data science teams to spin up whatever tool they need to work interactively. So you can use tools like SAS, tools like Jupyter, or tools like RStudio. And the powerful part about this is that these are the tools in their native form, And so we didn't try to reinvent Jupyter or reinvent these tools. It allows you to use them and leverage your existing expertise. The other way that we've seen people build and develop models is working programmatically using batch experimentation. So what I can see here is, here's a model that I recently ran, and I can see exactly what script I ran, this param search.py, the hyperparameters that I used, and Domino is automatically linking the input files, the output files, exactly what results I generated, and even the specific hardware and software environment that I used. This is all captured in Domino's underlying Docker-based infrastructure using what we call as the reproducibility engine. And this is critical because it ensures that teams can build on their past results and much more quickly hone in on that ideal optimal model that they want to publish. And so once teams have done that, then they want to, once they've got that model, they need to share it. And so, as Mike said, it's not just good enough to build a model, you need to integrate it into the business. So there's a number of different ways that Domino supports that. The first is with the Domino scheduler. And so what you can do is you can choose which file you need to execute and then deal with the specific underlying infrastructure that you need. So you can choose the compute tier you need, and also you can set up a specific schedule. This deals with that classic problem we talked about with ModelOps around technology bottlenecks that prevent teams from getting their models into production. Another popular way that we've seen teams do this is using web apps, tools like Flask or Shiny. And you can see here is I've actually already created a Flask app for this, and I can set specific permissions to invited users. So I could set this to my colleague Tim, and I can also set a description such that this is then available, and then I can have this show up in the Launchpad, which is the single catalog view for all of your business stakeholders to look at. So jumping over to that, what you can see here is I can see all the different models. If I'm a business stakeholder, I can see all the models, products that are available to me, and I can then dive into that. So I want to look at this app, and I now can see powerful interactive applications. And so this is a churn modeling app. A customer support associate could use this to help understand how to behave with a certain customer. And it also is able to use some of the powerful modern tools like Lime to help build interpretability into the product. And all of this is helpful because, as we said, it's not good enough to just build a model. You need to build a model product and encourage engagement of that. And as far as engagement goes, you can actually, if you're the creator of this project, you can start to see some details of how it's being used. But if you're the creator, you can actually see the specifics around how this model is being consumed. And so I can go to this usage tab, and I can see how this is being used, the different users of this. Obviously, this was published quite recently, but this allows organizations to know who are the people engaging with my products, and allows them to better know who to solicit feedback from as they go to make it better in the next round. The last way that we've seen teams integrate models via Launchpad is through APIs. And so what you can see here is a list of all the different model APIs that I have available to me. And I want to jump into this customer churn one. And what I can see here is this, I can see a brief description, and I can also see how to integrate this model into other systems. And these are code snippets that I could give to my application developers so that they can integrate this model into their applications, such as like a CRM or a customer-facing web app. The other powerful tool about this is that these things are versioned. As we talked about, one of the key challenges around ModelOps is this idea of iteration. And so you need to be able to see exactly how these things were built so that if you need to update them, you can trace back that full lineage of the model. And so you can see here, my colleague Josh built this. I can see the exact version of the project from when he published this. I can see the file. I can even see down to the function level. And I can also ensure that he's using an environment that is consistent from development to production. So no more package mismatches leading to errors in production model runs. And all of these models are horizontally scalable, backed by Kubernetes, which allows teams to ensure that they can handle web scale traffic. The last area of the product that I want to show is the control center. And the control center is a portal to understand how models are, all the resources are being consumed across your organization. So I can see how the spend is trending across my entire team, and I can also see that by hours. And I can dig into how that's working at a project level or at a user level. And this is essential for data science leaders and IT leaders to be able to understand how resources across their scaling data science teams are being used. And consistent with the Domino principle of openness, we expose this information as an API so that it can be integrated into other tools. So for example, you can integrate this into a BI tool like Tableau, and you can see here all the different tools, all the different views that you could create with all of this information. I can see my most used projects, my most active users. And ultimately, we believe that the control center, as part of Domino 3.0, is critical in conjunction with the Launchpad to helping teams better operate the entirety of their data science lifecycle: development, model operationalization, and then governing that whole process. We think that ultimately these are the critical ingredients to building an organizational capability around data science.
Thanks for going through the demo with us. As I said, if you would like a longer demo, we have that's available on the Domino website, and there's also more information there. But without further ado, I want to turn it over to Sammy Jern, who's the data scientist at Bayer, and she's going to talk through their use case and how they're using Domino to address ModelOps challenges within their organization. And I'll let her take it from here.
Thanks, Mac, for the introduction. So this is Sammy, and I'm a data scientist at Bayer Crop Science. And just a little bit about me. I started data scientist career for about 3 years now, and previously I was actually in mathematics in the academic setting. So this is a really different environment, but also we're learning a lot with working with a very diverse set of people from different backgrounds. So today I wanted to talk a little bit about some specific use case of how we at Bayer Crop Science is using using Domino to deliver some of the data solutions for our stakeholders. But before that, I'd just like to give you a little background of what we do at Bayer Crop Science. So we are primarily helping our farmers to deliver solutions that help make their life easier. And as you can see here, we actually focus on many different decisions that a farmer has to make at the beginning of each season. So they can be questions like, what seed do I plant? Where do I plant it? What kind of seed protection do I apply? What weed control do I use? So these are all different key decisions that are really critical for a farmer's season. And because you can only grow your crop once a year, and once you made your decision, you can't really go back in time and change it. This is something that's really important, both from a farmer and from our provider's perspective of the company that is making these seeds and making these solutions for our farmers. So as you can see, agriculture is actually a really data-driven field. So we have been leveraging these different types of data for our company for several years now. We have built a data science community at Bayer Crop Science since about 5 or 6 years ago, which is where it really took off. So by now we have about 500 people that are working in the data science space across different countries, and this community is growing. And of this community of 500 or so data scientists, we have about 75% of us that are using Domino for their day-to-day work. So this Domino platform is helping us to actually do a lot of cross-functional collaboration to improve more than 100 decisions. So specifically, these are decisions such as different research group, if they want a POC done, they can use Domino to quickly deploy something that is lightweight, that is impactful, without taking a lot of time. For example, another decision is for manufacturing, if they want to see what is the supply forecast for some of the crop, we use Domino to develop some of these models to deliver these model predictions to help them make decisions for the season. So with that, I wanted to go a little bit deeper about two particular use cases that we are using Domino for. And as Mac mentioned before, there were a couple of technology challenges in deploying data science solutions. In particular, for our case, it is not so much about building the most complex model, but it's also about getting the users to engage in our product, getting the consumers of our model outputs to understand and use the model-driven and data-driven solutions. So in this problem that we have in particular is actually in our supply chain organization. So my job as a data scientist, I work with a lot of stakeholders in our supply chain organizations that are really trying to solve problems at different time points of the season. So during the season in North America, for example, we can kind of divide this time into four different segments. So we have our production planning. So this would be asking questions like, where are we planting the seeds? What kind of seeds are we planting? How many are we planting? And the next thing is actually the physical operation of planting and harvesting. And then there is a processing and finishing stage because we're a manufacturing site. And after that, we also have to go through a stage of performance evaluation. So these will be kind of like asking the question of, okay, how did product A perform this year? And is this really the right place to grow this product? What can we do better for next year? So this, in turn, is a feedback loop for our next season's production operation. So in here, some of the bottleneck that we have in terms of how decisions are made is we were at a stage where a lot of people that are in the business, they rely mostly on manual data. So they're sending Excel spreadsheets, trying to make versions that are like V2, V3, and so on, and sending it to each other. So there's also not a lot of visualization to help us understand in a more in a more easy to understand way how we make these decisions. So what that resulted in is a lot of times the decisions were pretty scattered. It was not very consistent, and also definitely not reproducible because we're not doing the same thing every year. So with this problem, that's where Domino really comes in and to a very useful part. So the solution that we developed in our data science team is to leverage Domino to, first of all, we standardize the data consolidation process. So Domino is a platform that we can use to actually talk to our internal API. We also use it to grab data from S3, put data in S3, and then from there we can use different Jupyter Notebook, for example. We can use that to do a lot of data wrangling. We build packages to do models and also build visualization tool such as our Shiny app. And this is a quick example of how we were able to do that. So in Domino, and what I did personally is I found it really convenient is the Docker file setting that we can use to really have the control in our own hand on how we want to modify our computing environment. And from then, I can actually use that to build whatever tools that I want to build. So in this case, we actually have an R Shiny app that is a visualization of some of the performance metrics that our stakeholders are interested in. And the nice thing about this is I can actually just focus on building the tool itself and not worry so much about the engineering and the deployment of the tool, because Domino has a built-in publishing function where I can just put a link on from Domino and send it to my users, and Domino takes care of all the deployment work. So what I get from here is this one link that I can send to my users. Right here is my our Shiny app that I use, and as you can see, this is a link that I send to my share stakeholders, and then they can click on different information where they want to see the KPI for this particular management practice that they deploy on the field, and then they can check out, okay, how do we do this year, how do we do historically, and what we can do to make our performance better. So you can see this is a very easy way to make decisions for them because they see it right here. This is their data. So for us, this is a really game-changing tool because we were able to go from having to track down an engineer to help us deploy something to being able to do all of these work in one platform. And another use case I want to talk a little bit more about is the model operations perspective. So Mac mentioned before that user engagement is a really big part of data science model development, and so for us this is absolutely true. Although we are using a lot of data science and we are always talking about different models, we are still not just building a complex model. We are actually, more importantly, we are looking for user feedback. We're delivering value. And how we deliver this value is actually to have a two-way street and get our users' engagement to give us feedback so we can improve our model for the next season. So in this example, I wanted to talk a little bit about that same problem that we have in the supply chain operation, but at a different time point. So during planting and harvesting, what we do is we have this operational need of basically seeing what is the yield forecast for some of our crops. And some of the bottleneck in here is we don't really have a lot of, we didn't have a lot of buy-in from our stakeholders because data science at the time was pretty new. So it took us a lot of work to really get people to use our models and to use the model outputs to help them make the decisions. On the other hand, because it is so much work to deploy a model, a lot of times when we want to retrain a model, for example, and if we want to make any changes in our code, we have to really ask a lot of help from our engineers. So sometimes that could cause friction, right? And this is another example where we were able to use Domino to address a lot of these bottlenecks. And I'll show you how. So in this model, this is a supply forecast model, and I'm doing it all in Domino. And first, starting with choosing a custom hardware and create a computing environment in my Docker file so I can tell Domino, what Python packages I want to install, what version of Python or R I want to use. And after that, I can actually put all my code into this Domino project. And from the operational perspective, I was also able to run these scripts on schedule without the help of any cron job or any engineering resource to say. So this is actually a really big time saver for us because I was able to set a schedule, run it every Monday, and then it spits out the results for our stakeholder and for me, and then I can actually use that to tell my customer, for example, is, hey, this is our output, do you want to take a look and let us know what you think? But there's also a really useful tool that I found really important from Domino is the launcher function. So as I mentioned before, it is really important for us to engage our users to help them use our models, but also to get feedback from them on how we can improve on our model. So with launchers, I was able to actually build a user-friendly app that connects the script that I built to a user's button. So in this case, the stakeholder can just go in the Domino project and check run, and what he sees is the model input, so the data that goes into the model that provides predictions for the supply forecast that he will ultimately use to make decisions in the operation. And the benefit in here is that he can actually tell me if there's something that looks wrong. I can go back and check the data sources. So this actually would bring a lot more visibility into the model and also helps our model development lifecycle smoother and better. So with that, I just wanted to wrap up by saying some of the impact that we were able to get using Domino. So first of all, with our stakeholders, we were able to provide actually a lot more convenient access to the results that are trackable, shareable, and also faster, and enable them to make faster and smarter decisions. So the two examples that I went over, so the first one is the RShiny app. This is where they can actually use it to make a shareable visualization tool that help them make decisions faster. The second example where we were able to use a launchpad for them, for our users to help see the model input. So this is also a way for them to track the model output and input so they can see what comes out of the model. For data scientists, Domino allows us to really focus on the innovation because we don't really have to worry too much about the computing environment, the model deployment perspective of things. So this is actually really a big time saver for us. We were able to work more on the cool ideas, focus more on the engagements of users, and also collaborate with different data scientists. And one more thing, finally, is the data science lifecycle. So because Domino is a perfect bridge between engineering and data science, we were actually able to use Domino to deploy a lot of POC in a lightweight manner. So what that means is it helps us kind of speed up our data science lifecycle because then we can discover our products faster and also easier with less dependency on different types of resources. So with that, I just want to say thank you very much.
Thanks, Sammy. I really appreciate you walking through in such detail how you guys are using the product, and to say thank you to Mike also for helping set the stage at the beginning. If you are curious and you want to learn more about Domino 3.0 or Domino generally, feel free to check out our website. I've got the URL here, or feel free to reach out to us directly. We'd love to chat with you. Last time, I'd love to say thanks to everyone for being involved. If you have questions, feel free to have left them in the chat. We'll follow up with people specifically via email. And overall, have a great day, and thanks for everyone's time.